Well, look at this question here. Aria is planning to invest in a new machine costing 150,000. The company anticipates that the machine will generate additional cash flows of 50,000 per year for the next 4 years. The discount rate for these cash flows is 10% per year. Required. What is the present value of the expected cash flows from the machine over the next 4 years when it's discounted semi-annually? Number two, how will the present value of Ara's investment change if the discount rate increased to 12% annually and had been discounted quarterly? So here again, dealing with annuities. Now with these questions, you always have to check to find out if the payment period and the discounting period are equal. Okay. Now here for part A, they've told us the cash flows are per year. Okay. But these cash flows are being discounted semi-annually. Okay. So the discounting period and the payment period are not the same. Okay. The discount period is semi-annual, which is twice. The payment period is annually, which is once. So we need to find a way to equate them. Okay. So one way we can equate them is where we use the effective annual interest rate. Okay. The effective annual interest rate is going to convert this semi-annual discounting period into an annual period. Okay. Because as I said, the discounting period and the payment period should be the same. Okay. So this we're going to first apply the effective annual interest rate. This is the formula. 1 plus the rate over the number of compoundings raised to the number of compoundings minus 1. Okay. So here, since the discounting period is semi-annual, so the number of compoundings is 2. Okay. Because it's semi-annual. Okay. So you're going to say 1 plus the rate, which is 10%, converted to the decimal 0.1, divided by 2 raised to the power 2 minus 1. 0.1 divided by 2, that is 0.05. Then you're going to say 1 plus 0.05, that's 1.05. 1.05 squared is 1.1025. And then we're going to subtract a 1. You're going to get 0.1025 or 10.25%. Okay. So now we've made the discounting period annual. From semi-annual, we've made it now annual. All right. So now the discount period and the payment period are equal. Any questions before we move further? Then we can now calculate the present value of this annuity. Using the formula present value equals cash flow multiplied by the annuity factor here. So for our rate, we're going to use the 10.25%. Okay. So you're going to say 50,000 multiplied by 1 minus 1 plus the rate raised to the power negative 4 divided by the rate of 0.1025. Yeah. Once we do these tabulations here, we get our present value of 155,000 92 kwacha 50 ngwe. So this is the present value of this annuity, 155,092.50. Any questions? Yes. So that's what you should look for in some of the questions. You have to make sure payment periods and the discount periods are equal, or sometimes payment period and the compounding period, they should be equal. Other times you hear yes, they'll use the they'll use the word compound. So you have to make sure that they are equal, right? So this effective annual interest rate, you only use it when the payment period, yeah, when the payment period is greater than the discounting or compounding period. Yeah, when the payment period is greater than the discounting or compounding period. Okay, that's when you use the effective annual interest rate. Okay. Then if the payment period is lower, payment period is lower than the discounting or compounding period, that's where you are going to divide divide the interest rate by 2 and the time multiplied by 2, or the periods multiplied by 2. Then part B is saying that how would the present value of Aria's investment change if the discount rate increased to 12% annually and had been discounted quarterly? So here, since the discounting is now quarterly, so again we're going to use the effective annual interest rate to make it to make the discounting yearly. Okay. So when it's compounded quarterly, M equals 4. Okay. So here, 1 in the effective annual interest rate formula. 1 plus the rate 0.12 divided by the number of compoundings 4 raised to the power 4 minus 1. When you say 0.12 divided by 4, it is 0.03. 1.03 to the power 4, you get this value. Subtract it from 1, you're going to get 12.55%. Then we come back to the present value formula. Then, yes, so here we're using the rate of 12.55%, as you can see here. It's a 50,000 multiplied by 1 minus 1 plus 0.1255 to the power negative 4 divided by 0.1255. After we do our tabulations, we end up with a present value of 174,035 watch. So we compare against the other one. Okay. So the present value actually increases when the discount rate and the number of compoundings increase. Also the present value has increased. Okay, because they asked, I think, what part was this? This is how would the present value of Aria's investment change if the discount rate increased to 12% and had been discounted quarterly? So when the discount rate and the number of compoundings increased, the present value increased.